So I'm going to talk about a new feature of ScalaTest that is coming out in ScalaTest 3.0 called Async Testing. And what I want to start with is talking a little bit about the past. That is the way you handle GET in the Java Servlet API. How many people here, out of curiosity, have ever used that API directly? Oh my God. I didn't realize there'd be so many old people here. So the way this worked is you implement this method. It takes a request and a response object, and the response object is like a wrapper for a socket that's directly connected to the client. So you look at what was in the request, and you send things to the client, and then you return. The result type, there was no result type, it's Java, that was void. So when the method returned, the request response was finished, right? So that wasn't very reactive, and so one of the things our Play and Spray kind of web frameworks did was allow you to return a future response. So you can also just give a synchronous response in Play, and it looks like this. So here, if I have some intensive computation that comes back to me as a future, I can block on it with a wait. But this is uncool, right? I'm not supposed to do that. But what that await.result does is you pass it a future, and then if the future completes within 30 seconds, it will actually return the result. And then what you did is block the thread, and then when it's done, it will return the response. So that's sort of the unidiomatic way to do things in Play. What you should do is return a future response. So when I get my future integer back, I just map onto that to get a new future of type response, and I can return that to Play. And what Play does is it puts that on a shelf, and then when it completes, it has a side effect of completing the request response cycle. And the point of it is that modern JVMs, in practice, you can only create a couple thousand threads before the context switching starts to dominate, and it degrades performance. So it lets you make more use out of your threads. When a thread is blocked, it's not being used, essentially, right? So this whole async testing thing came, it started with an idea I had, or almost a panic I had, when I was teaching the company formerly known as TypeSafe's Play course. It was in Palo Alto about 2 years ago or 2.5 years ago. And we say this, that you should not block, you should return a future to the web framework. But the place that you might block is in tests, right? So it's generally accepted that it's okay to block in tests. So this is an example of a test where I've grabbed a future. I've got a future int, and I block on it until that int comes back, and then I perform an assertion. So it's kind of like the 3 rules of reactive programming are: rule number 1 is never ever block. And I've seen folks from the company formerly Lightbend have that in big block letters. Never ever block. That's sort of the mantra. So rule number 2 is never ever block, right? But rule number 3 is, well, all right, maybe it's okay someone's blocking your test. And so I was sitting in this class because my partner Dick Wall was teaching, and I was ignoring him, looking at the code, the test code, and thinking, this is kind of wishy-washy, right? Why is it okay to block in your test? And could that be my fault, right? So that was what I was thinking. Essentially, if you can return a future response to a web framework, why can't you return a future assertion to a test framework? That was what occurred to me. And so it would look something like this. It would look similar to the thing you give back to Play. If I have a future in hand in my test, I just map an assertion onto it and return that future assertion to the test framework, right? So I thought, well, that's interesting. Why don't I ask the Akka folks? So I emailed Roland Kuhn and Victor Klang and Jonas and Heiko and just said, well, does that sound interesting to you? And they said, yeah, I mean, they were positive, but I didn't really get the feeling there was a burning need. So one of the things I try to do is not just because an idea pops into my head, I try not to just stick it in. because already ScalaTest has grown really too big, and I don't want to have anything in there that isn't really needed. So I didn't do too much, but on a train ride to Colorado from California, I had a day, and I actually just coded up kind of a mock, or not a mock, but like I coded up to see if it would work, and I got it something to work. I found out like a way to I thought it could fit into ScalaTest to do something like this, but still pretty much wasn't sure I would put it in because I thought, you know, there really wasn't this burning need, and it would add surface area. And then later we decided to support Scala.js so that you could run ScalaTest on JavaScript as well as a JVM. And that turned into, I call it a Trojan yak, because we thought it would take 9 days to do that, and then it's still not done over a year later, right? It turned into this huge project, and half of it was async testing. And so what happened is that in JavaScript we learned that you can't block. The way JavaScript works is they just have one thread going around in a circle, and there's a queue of events, not events, queue of jobs to do, and that thread will pick up a job, do it, pick up another job, do it, pick up another job, and do it. It's just one thread. It's kind of like the AWT or swing event queue, right? Or a thread. And one of the things the job can do is stick more jobs at the end of the queue, right? So you can't block if there's just one thread, right? So we thought that after 6 months of slogging that we had finally, shaved completely the yak. And then we got this. I was about to release candidate 1 of 3.0, and I got this issue posted that this isn't working on JavaScript. And it's this feature value it's like a weight, but it's a ScalaTest thing where if you have a feature, you can call that feature value on it, and it will block. And it takes an implicit patience to decide how long to block. And if it completes within the time frame successfully, then it just returns that value, and then you can do an assertion on it. So it's the same kind of blocking first and then asserting. And what it turned out is that JavaScript can have multiple threads going on because you can call outside the JavaScript VM, and then there can be more threads out there. So there's just one JavaScript thread, but if one of the things that thread does is call into an API that actually goes into C or Java, right, some land where they actually have multiple threads, that stuff can do something that takes a while, and sometime later come back and stick something on the bottom of the JavaScript queue. So you can actually have things going on concurrently in your JavaScript, and that's what this person's sample service.getData was doing. It was going outside, and then we, of course, would not wait, so we would finish too soon, because you can't block. I mean, what we did for feature value is it just doesn't block. It assumes the feature's finished, and we did that thinking that it'd be good to have the same code running on the JVM and on JavaScript. And if you use the run now execution context in JavaScript, that will work. So anyway, when I saw that, I knew that the only way to fix that was to support async testing, because he's got a future. If you can just map this assertion onto that value, onto that future value, and return it to ScalaTest, and then ScalaTest, even on JavaScript, can just have it sitting there on a shelf. When that feature finally completes, and the way it'll complete is something will come from outside, stick something on the JavaScript event queue, and that thread will eventually get to it, and then the future will complete. At that time, ScalaTest can send an event to the reporter, which is kind of like the web framework sending a response to the client. This is the test framework sending an event to the reporter that's going to say test failed, test succeeded, right? So that took another 6 months. And so to give you kind of an idea of what that is, I'm going to back up again and explain a few concepts. One is this thing called outcome, which I introduced in 2.0, which is just a small ADT that models the outcome of a test. So a test can either succeed, it can fail, it can be canceled, or it can be pending. And succeeded and pending are just singleton objects. Failed and canceled have an exception inside of them. So that's outcome. And then there's a with fixture method in Suite that takes a test function, and the type of the test function is it doesn't take any parameters, and it returns an outcome. And then what the withFixture method does by default is it just invokes that test function. That's how a test gets executed. And then it returns the outcome that comes back. So the test function may return succeeded, it may return pending, whatever it does. In this case, by default, it just returns that. And this will be invoked for every test so that you can override withFixture in your own test class and do something before and after. It's not actually before and after, it's at the beginning of the test and at the end of the test. So the test has already started when withFixture is invoked. The test has not yet completed when the test function returns. So you can do things like retry it or change the outcome, that sort of thing. So anyway, that's what you might do in your subclass is do some setup, and then in a try, invoke the test function, and then in a finally, do some cleanup, right? Except there's one thing that I recommend people do, which is delegate to the superclass to invoke the test function instead of invoking it directly. I recommend you do this, which is super.withFixture test, because at the end of the chain, it's going to do the one on top there, the default one, and invoke the test function. So these guys actually stack. So you can compose withFixture methods as long as you call super.withFixture. So anyway, that was 2.0. And then one thing, most of the time people did that just in their test classes. Actually, I think a lot of times people use before and after because they're used to it from JUnit. But I make you mix in a trait because this was supposed to be the default way to do it. You don't have to mix anything in. It's just in there. It's in suite. But most uses of withFixture were in the test class because you just make one and you use it in that test class. But if you're using the same withFixture in several test classes, then you can pull that out into a mix-in trait that you then mix into those test classes. So it's just one with whatever the name of your trait is. You get that withFixture override. And that looks like this. Separate traces is actually one in ScalaTest that does this. You extend suite mix-in, you have a self type of suite, and then you override one of the lifecycle methods, in this case withFixture. What this one does is it for a test canceled exception or test failed exception, it will actually take off the top part of the stack trace that is above exactly where the assertion was that failed. So it's changing the outcome by if it's a stack depth exception, it will truncate or chop off part of the stack trace. So to summarize the past, users can define withFixture methods. You can compose the withFixture methods by stacking traits. And according to the types, and this was the issue, that the test has already completed what the test function returns. So it's kind of like the servlet API in that if you just look at the types, it kind of forces you to block because when it returns, the response has finished. It has to have finished because there's no way to sort of continue it. And so that was sort of what we had to work with to add async testing. So one of the first things we did was, I struggled with a future of what. So I'm going to actually just demo this one so I can write some code. Assert x equals 1. In 2.0 and earlier, that returned the unit singleton. And it still will do the same thing if it fails. It will throw an exception because otherwise all the code would break in the world. So it still does the same thing as it did before, but instead of returning the unit singleton object, it returns the succeeded singleton. I just reused that. And then I made a type alias, which is org ScalaTest assertion. That's just a type alias for the singleton type of succeeded.type. So assert has to return a singleton object. But it doesn't have to because if it fails, it throws an exception, right? And then matchers also, like say x should equal 1. That returns a succeeded, and if you say 2, that blows up with the same exception. So basically that was one thing I did, and the reason is that I didn't want the type of test to be future any or future unit because it just sounds wrong and it seems very error prone. I wanted to be able to say you return a future assertion to ScalaTest, just like you can say you can return a future response in play or spray, right? So what is assertion? Well, that's what it is. It's actually the succeeded object. Okay. And then we just did that. So, well, we did it by adding bloat. And this was one of the real struggles I had, was trying to, like, it was already really big and I didn't want to make it bigger. And that was sort of why I was skeptical of adding this feature in the first place. But Scala.js actually provided the burning need. I had to do it. If either I don't support Scala.js or I add async testing somehow, right? So the way we did it is, for every of the many style traits, there's now an async flavor. So for word spec, there's async word spec. And the difference is that async word spec, the result type of the test is future assertion. And there's also an implicit conversion from assertion to future assertion, so that if you want to mix in some synchronous tests in the middle of also some async ones, then you can, right? But that's what it looks like. And then, in fact, that's the, how that person could rewrite the code now. The person who, his name is Code, actually, K-O-D-E. This guy, I forget his first name, Chandra Sekhar Code. So he's the one that found the problem. So to rewrite this now, he would just extend async fun suite, not use Scala features, and just return a future assertion. Just map the assertion onto the existing future. So that worked. But I had to figure out what to do with this, because this, the types say the test has completed when the test function returns. And now when the test function returns, we have a future something. We have a future assertion to start with. So what I ended up finally doing is adding two more types. So suite now has two subtypes, test suite and async test suite. And these are where the type of the test function is defined. There are a lot of other ways that we thought of all different ways to try to make it as simple as possible. And this is what we ended up with. So the ye old with fixture that you're used to is now in test suite. And there's a new one in async test suite where instead of outcome, it's future outcome, which is actually a new type. And what future outcome is, it's like a future square brackets outcome, but with a nicer API, because the problem is that future, when you work with it, you'll get a try, which is either a success or a failure. And then if it's an outcome, that's either a succeeded, a failed, a canceled, or a pending. So if you want to actually map, deal with a failure somehow, you have to catch success, failure. And I just thought that would be confusing to people because they're too similar. They both handle exceptions, but in different ways. So I just wrapped it with something, and now there's just an API that is very much the ScalaTest domain language. It's like ScalaTest terminology. So that's called future outcome. So the test function in an async style returns future outcome. The with fixture method returns future outcome. And the default implementation just invokes a test function again. So that, I may leave that as a breaking change. I think I can actually find a way to deprecate it. I think that may be possible. I will see, and if so, I will. But all you need to do to fix it is just put the word test in front of it. So it won't break any code where you just overrode with fixture in the test class, because that is inherited from test suite, so that's fine. But if you actually pulled it out into a mix-in trait and overrode with fixture, the mix-in trait you can override a bunch of different lifecycle methods. If you actually overrode with fixture, then that will eventually be broken, and you need to put the word test in front of suite in those two places, and that's it. So I think that's not too bad, because people didn't do that terribly often. Okay, so then now basically you're in future space, and I think the thing about, I mentioned there's a different mindset you have to do, and it's really just the monad mindset, that what happens in the monad stays in the monad. Basically, you don't ever want to block and pull the thing out of it. You want to just sort of stay in future space, right? So a bunch of things didn't work anymore. One of them was try finally. Let me back up and remind you try finally again. See this try finally here, where you try in delegating the invocation of the test function, and you do some setup, you sort of invoke the test function and try, and then finally you do your cleanup. If what your test function is returning is a future outcome, then you don't want to do cleanup that soon. You actually want to wait until the future completes. See the problem? So what I created, instead of try finally, there's complete lastly. And the reason I picked that is because this is not fixed width font, but in fixed width font, those two curly braces at the end line up. But it's like try finally, but for futures. And it will work on anything. I had to create a new type class, so it's called futuristic, which I thought was cool. So it will work for any type T where there's a futuristic of T defined, and I defined one for future outcome and any other kind of future. So it'll work in your test code on futures also. And what it will do is if that blows up, like if the code that produced some futuristic thing blows up with an exception, so instead of try, it's complete the future. If that blows up with an exception, because it could, it will actually execute the code in lastly, just like finally. But if it returns, it's different than finally. It doesn't execute it at that point. It just registers a callback on that future to execute when that future completes, and it returns a new futuristic thing that won't complete until that callback is completed. So that's the other problem with like the futures API, like future square brackets outcome. It didn't quite fit because I always wanted to give a new future back that didn't complete until the cleanup happens, the callback finishes. So there's an on success, on failure, and on complete that won't wait. I mean, they'll just do it off to the side. There's an and then on future that will wait. So it gives you a new feature back that doesn't complete till that thing finishes, so you can order your callbacks. But if that thing blows up with an exception, it just ignores it. And I didn't want that. I wanted it to behave the same as synchronous. So if, in a complete lastly, if the what's in lastly blows up with an exception, the future that complete lastly returns will actually show that exception. So, and because if the finally blew up in synchronous case, that test would fail with that exception, right? So that's complete lastly. So that's one example of something new that we had to invent to sort of support this. Another one is now that there's a result type of assertion, some things wouldn't work anymore. And so, like for example, intercept is an assertion that will make sure a exception is thrown by a bit of code, and then return it so you can perform more assertions on it. And so people use that all over the place, including at the end of tests. But that's not type assertion. That's type, in this case, string index out of bounds exception. So that actually wouldn't compile in an async suite if that was at the end of the test body. So I created an assert throws that does the same thing but doesn't return the exception. So that's new. So that you could stick at the end of an async style test. If you actually want to say that you expect a future will fail with an exception, which is something you might want to say in an async test now that you got to stay in future space, neither of these work. You can't really map that future and then add an assert throws because, well, first of all, there's nothing to put in those dot and the dot there, and map won't even be invoked if that test function won't be invoked if the future fails. And likewise, if you put assert throws around the future, it doesn't throw an exception. It just fails, right? So we had to create two new things that are kind of like intercept and assert throws, but for futures. And one of them is recover to exception. So the future API calls it recovering if you are go from an exception back to some kind of success. So I had one called recover to exception if illegal state exception. So it's like recover in future, except it has to be that exception. Recover will do it if any kind of exception it will recover from. This one won't recover from the wrong exception. It'll give you a test failed exception that says, hey, I expected this exception, but I got that one, right? So you put a future inside that. And then recover to succeeded is like assert throws. It does the same thing, makes sure that the future fails with that exception. But if it does, it doesn't return it. It returns succeeded singleton, so that can end up at the end of a test if you want. So that's recover to. And there's actually a lot more to the story. What I thought, one of the questions is let me go back up to the diagram here. So imagine you've got 10 of these tests and they all return a future assertion. Do they run in parallel? Because it's kind of like the idea of this stuff, right? That you might expect they should. And so I thought, well, okay, why not? And then people said, actually, can you make it not run in parallel? Because they would put some kind of fixture that they wanted all their tests to share, like a database, and they didn't want them to interfere with each other. So by default, they don't run in parallel, which is kind of weird, but they don't. First, they run asynchronously, so it could be many different threads, potentially. But the first one finishes before the second one begins, and that one finishes before the third one begins. Okay, so that's one thing. And then whenever you do future.map, you need an execution context, right? And there isn't one, so I actually at one point made you create one, but then I actually thought, well, that's boilerplate. Why don't we give people a default? And the thing I was worried about with the execution context is like it's usually a thread pool, like it's multiple threads, because the whole idea is to use multiple threads. But that makes people reason about, like in tests, people will make mutable fixtures and stuff. I mean, they're not as functional sometimes. And so if you're using mutable state, you need to worry about synchronizing access to shared mutable state. And if in a future, if you just do a linear transformation of futures, even if it's having side effects and mutating state, it will actually work because of what future does. It will synchronize it. But it's hard to know when you don't follow the rules, and now you've got a concurrency bug in your test. It's not so terrible in your test, but it could end up with a flicker and waste people's time. So what we did for a default execution context is made one called serial execution context, which nobody can access, but it actually just remembers what you asked it to do. Like it actually makes one of those little job queues. So the thread that goes and executes your test body and returns a future result, anytime it needed an execution context, it would remember that thing to do and put it in a queue, a list of to-do list. And then that same thread is used to execute that queue. So that's the same thread. It's called thread confinement. So you don't have to worry about synchronization. It also means you can't block because like JavaScript, there's just one thread now. So if you actually use the default execution context and do one of these blocking things, it will just hang forever, which I think eventually you'll figure it out, that one. But I thought, so we did that, but then it's like, what about on JavaScript? So on JavaScript for a while, we did not use that one, but then we started using it because we thought, I wanted it to be consistent. And I think it's valuable that you write, people want to share code between the JVM and JavaScript. That's sort of the point of Scala.js, I think, is people who are already using Scala and they have to make JavaScript, if they can actually share some code, and that's end knowledge. So I just wanted as much as possible to make it work the same. So that's what we now by default, even on JavaScript, the default is serial execution context. So if you really want to do something multi-threaded, and that's what I'm kind of concerned about with JavaScript, if you want to do something multi-threaded, you got to add a different execution context. Override this one with a new one, and on the JVM also, because if you really want a thread pool going, then you just make a new execution context. So I did try to, like I said, try to make these two things consistent to help people go back and forth. Before and after work, because any kind of after code is registered as, on a future-like thing, and the new thing that comes back doesn't complete until the after code finishes, right? So I still recommend with fixture, but if you use before and after in future space, it actually works. You're just doing side effects at that point, but they happen when you think they would happen. And parallel test execution works too. That's how you do get parallel test execution. And what's weird, which I didn't think made sense, but it turned out it actually did, is it works on JavaScript too. And it's like, how can you have parallel test execution have any value at all if you just have one thread, right? And the reason is imagine you have those 10 tests, and each one calls into one of those APIs that does something for 30 seconds, and then later comes back and sticks something at the end of the JavaScript queue. It'd be nice to get them all started, because it really is multi-threaded. Instead of taking 30 times 10, 300 seconds, it could take closer to 30 seconds to finish that suite of tests. So my hope is, and I thought I was close to finishing this. I thought I was close to RC1 twice before, and I got one of these issues that took another. So I probably shouldn't say this, but that last line. I don't want to tempt the universe with another very, bold release. But I think we really are there, hopefully. So I just wanted to leave some time for questions. So we have time for questions. But before that, I did want to say that, whoops, I went backwards. Nerman and Andrew, who did this puzzlers book, are here, and we're going to do a book signing after Christopher's talk. And we're going to give away 3 copies. And we usually throw out these puzzles, but we didn't get that organized. So we have my business card, like this out-of-date business card, and I put a puzzle on back. It's a really softball. It's not a trick question. If you come over and bring this and solve the puzzle, we'll give you a free copy. But anyway, we'll be out there at the break. But I like to try to throw them, but I don't want to hit anybody in the eyeball. So everybody wake up. I'm going to go 1 in the middle of 1. Hey, there's three rows. It's perfect. So way over there. And I'm trying to, oh. All right, wait. That was practice. I hit my... We needed a duh, don't quit my day job. Yes, all right, let me try that again. Huh? Oh, there you go. Look at that. It just floated down like snow. Those guys are really fighting for it. You can see that they... all right. There we go. Sorry, I'm going to have to get it in the back here because I'm not... Crumble it up. That's my business card. Oh, well, they don't... I'm sorry, people in the back, but it's like the eager people in the front get the free copy. And the other thing is of course, other thing that's free is these stickers. If you want any ScalaTest stickers, we made some of those. But I'll have them out on the table. But anyway, I have 5 minutes for questions if somebody has questions. Yes. Let me get my glasses. Yes, go ahead.
All right. So we've been using the when ready. So do you recommend with 3.0 to stop using when ready, or is that being deprecated?
Not being deprecated. So the question was, they've been using when ready, which is also in that Scala features thing, which I forget where the example was. When I said future value, I think it was actually in his code. Yeah, it was in Code's code. Where's Code's code? Somewhere. Here it is. So this future value. Another construct in Scala features is when this feature is ready, it'll pass it in and you can do an assertion. So that's blocking. It won't work on JavaScript, but it works fine on Java. And the other thing that's a little weird is usually this stuff's about never ever block, right? So that's blocking, but it's not necessarily bad in a test. Now I sound like being wishy-washy again, but the reason is because one of the other reasons we had this serial execution context is that if it's really doing something asynchronous, then what could happen is that the queue empties, there's no more jobs to do, but the test hasn't finished. So what we do in that case is we block. So we actually block by default with the serial execution context. And the reason is if I didn't do that, in other words, if you always use the global execution context as the default or something, you could get in a situation where 500 tests start at once because there's nothing throttling them. And then you get so many going that they time out, right? So so even if you use this, it still might be blocking a little bit behind the scenes to throttle how many tests are running at the same time. Thank you.